July 1963. The grandstands at Daytona were shaking. Engines screamed down the banking at nearly 180 miles per hour. Spectators watched as America's biggest automakers fought for dominance on NASCAR's fastest tracks. Ford was winning, Chrysler was fighting back, and Chevrolet? Officially, Chevrolet wasn't even supposed to be there. General Motors had withdrawn from factory-backed racing years earlier. Publicly, the company wanted nothing to do with motorsports. Executives claimed racing didn't matter. They told shareholders that performance development was wasteful. They insisted that quiet, reliable family transportation was the future. But behind closed doors, engineers were working on something so radical, so experimental, that even many people inside Chevrolet didn't know it existed. A secret engine, an engine built for one purpose: beat Ford. And if it destroyed itself in the process, that was considered acceptable. Most people have heard of the legendary 427 big block Chevrolet, the engine that powered Corvettes, Camaros, and some of the most feared drag cars ever built. It became synonymous with American muscle. Kids hung posters of cars equipped with it. Street racers whispered about it with reverence. Drag racers built entire careers around mastering its explosive power. But what almost nobody knows is that before the famous production 427 arrived, there was another engine, a mysterious machine that appeared suddenly, dominated NASCAR, terrified competitors, and then vanished almost as quickly as it arrived. It became known as the mystery motor, and the truth is, this legendary engine was never meant to survive. To understand why, you have to go back to one of the most intense horsepower wars in American history. By the early 1960s, NASCAR had become a battlefield, not a gentleman's competition, not a friendly showcase, a war. Ford's high-performance FE engines were getting stronger every season. Engineers in Dearborn were pouring resources into racing development. Corporate leadership understood the value of victory. Every win meant headlines. Every headline meant showroom traffic. Every showroom visitor meant potential sales. Chrysler's Max Wedge program was producing monstrous power. The engineers at Mopar weren't playing games either. They understood that reputation mattered, that dominance on the track created mystique on the street, that young buyers wanted to drive what they saw winning races. Every manufacturer knew one thing: win on Sunday, sell on Monday. Race victories translated directly into showroom traffic. Dealerships reported spikes in interest every time their brand won a major race. Salespeople could point to trophies and lap times. Customers could imagine themselves behind the wheel of something connected to victory. It wasn't just marketing, it was proof. Proof that your engine could handle punishment. Proof that your engineering was superior. Proof that when pushed to absolute limits, your product survived while others failed. Chevrolet engineers understood the problem. Their existing 409 cubic inch W-Series engine was famous thanks to songs, drag racing victories, and impressive street performance. The Beach Boys had immortalized it. Hot rodders loved it. Magazine tests showed respectable numbers, but on NASCAR's high-speed superspeedways, it was reaching its limits. The engine used an unusual combustion chamber design built into the block instead of the cylinder head. It worked, but airflow wasn't ideal for the future. The design had been innovative when introduced, but racing demands were evolving faster than the architecture could adapt. Ford's engineers were finding more power every season, every month, sometimes every week. Chevrolet needed something completely new and fast, so a small group of engineers began working in secrecy. Not in the main development facilities where hundreds of employees worked daily, not in spaces where corporate executives regularly walked through, not where accountants tracked every dollar spent. In quiet corners, in off hours, in spaces where questions wouldn't be asked. Their goal wasn't simply to improve the 409, their goal was to replace it, completely. The project became known internally as the Mark II. Today, enthusiasts know it as the mystery motor. The design was revolutionary for Chevrolet. Instead of the unusual W motor architecture, engineers created a completely new big block layout. They started from a blank page, no compromises based on existing tooling, no limitations from previous designs, just pure racing engineering focused on one objective: maximum power. The engine featured canted valves, improved breathing, larger ports, and a stronger block designed specifically for racing abuse. The valves were angled to optimize airflow in ways the 409 never could. Port shapes were sculpted for maximum efficiency. The block itself was reinforced in areas where racing stress concentrated. Every decision served performance. The numbers were impressive. Displacement measured 427 cubic inches. The bore was approximately 4.25 inches. Stroke measured 3.76 inches. Compression ratios varied depending on configuration, but race versions pushed well beyond 12:1. Some experimental versions reportedly exceeded 13:1 for qualifying runs. Numbers that made fuel quality absolutely critical. Numbers that demanded precise tuning and constant monitoring. Horsepower figures officially hovered around 430 to 450 horsepower. Unofficially, many insiders believed the true number exceeded 500 horsepower in NASCAR trim. Some whispered about even higher figures, numbers that would have shocked the public, numbers that would have alarmed GM executives, numbers that stayed secret, and that was a problem. Because power wasn't the only thing engineers were chasing, they were chasing survival. At Daytona and Talladega, engines spent hours at full throttle, not seconds, not minutes, hours. Imagine holding your engine at redline for 3 hours straight. The heat, the vibration, the relentless mechanical stress on every component, every bearing, every valve spring, every piston ring. Temperatures climbed relentlessly. Oil pressure fluctuated. Connecting rods stretched. Bearings suffered unimaginable punishment. Valve springs fatigued. Gaskets deteriorated. Every weakness eventually revealed itself. An engine that looked fantastic on a dyno could become scrap metal after one race. And the mystery motor quickly revealed its weaknesses. Early testing exposed serious durability concerns. The engine breathed beautifully. It made tremendous power. Drivers reported throttle response that shocked them. The torque curve was unlike anything Chevrolet had produced. Acceleration off corners felt violent, but some internal components weren't ready for the punishment. Oil control became a constant battle. At sustained high RPM, certain areas of the engine received less lubrication than engineers wanted. The oil couldn't reach everywhere it needed to be. Passages that worked fine at street speeds became inadequate at racing speeds. The windage from the crankshaft whipping through oil created foam. Aeration reduced lubrication effectiveness. Bearings showed signs of distress. Mechanics would inspect them after test sessions and see discoloration. Witness marks, tiny scratches, warning signs that lubrication wasn't adequate. Valve train components experienced unusual wear. Springs began showing fatigue faster than predicted. Rocker arms developed witness marks. Pushrods showed stress. Mechanics would tear down engines after testing and discover metallic debris in oil pans. Small flakes, tiny particles, tiny warning signs. Warnings that something wasn't right. Engineers scrambled to identify sources. Was it bearing material? Cam lobe wear? Ring material? Every teardown became an investigation. Every particle told a story about what was failing and why. But there was no time. No time for leisurely development cycles. No time for years of testing and refinement. No time for the careful, methodical engineering process that normally preceded production. Ford wasn't waiting. Chrysler wasn't waiting. Racing seasons don't stop for engineering problems. Competitors don't pause while you solve issues. Victory doesn't wait for perfection. So Chevrolet pushed forward. Engineers worked frantically. They modified oil passages. They changed bearing materials. They experimented with different valve spring configurations. They reinforced suspected weak points. And then the real nightmare started. At race speeds, the mystery motor was producing power levels that stressed nearly every part attached to it. The engine itself was just the beginning. That power had to travel through the entire drivetrain, through the clutch or transmission, through the drive shaft, through the differential, into the axles, out to the wheels, and every component along that path was suddenly being asked to handle forces it was never designed for. Transmissions failed. Gears shattered under loads they couldn't withstand. Synchronizers disintegrated. Cases cracked. What had worked fine with less powerful engines became grenades waiting to explode. Drive shafts twisted. literally twisted. The torque would exceed the shaft's torsional strength, and it would deform, sometimes gradually, sometimes catastrophically. Engineers examined failed shafts and found them wound like corkscrews. Rear differentials exploded, ring gears shattered, pinion gears stripped teeth, carriers cracked. The entire rear end would disintegrate in spectacular fashion, usually at the worst possible moment. One crew chief reportedly joked that the engine was so powerful it spent half its time trying to destroy the rest of the car. And he wasn't entirely joking. The sheer torque generated by the big block shocked teams accustomed to smaller engines. Everything had to be upgraded: stronger transmissions, reinforced drive shafts, heavy-duty differentials. Even suspension components needed attention because the forces involved in accelerating that violently stressed everything. Every weakness in the drivetrain suddenly became visible. Components that had lasted entire seasons now failed in single races. Parts that seemed robust proved inadequate. The mystery motor exposed limitations throughout the entire vehicle. Yet despite the problems, the engine's potential was undeniable. Drivers loved it. They could feel the difference immediately. The massive torque pulled hard off corners. Acceleration onto straightaways felt entirely different. The improved breathing allowed the engine to keep making power at high RPM when other engines started gasping for air. Long straights became opportunities rather than obstacles, places where the mystery motor could stretch its legs and demonstrate superiority, places where Ford's best efforts could be challenged, places where races could be won. Ford teams noticed. They had to. When a mysterious new Chevrolet power plant starts appearing near the front of the field, everyone pays attention, especially when nobody knows exactly what's under the hood. Ford engineers wanted information. What displacement? What compression ratio? What cylinder head design? What valve train configuration? Nobody was talking. Chevrolet teams kept hoods closed. They covered engines during transport. They limited access to teardown areas. They created deliberate confusion about specifications. That's how the nickname was born, Mystery Motor. Nobody outside a small circle of engineers truly understood what Chevrolet had created. Rumors spread through garages. Some believed it was a modified 409, a bored and stroked version with new heads, an evolution rather than revolution. Others thought it was an entirely new engine family, something designed from scratch with no compromises. A few suspected it was experimental technology that might never see production, a pure racing prototype that existed only to win races. The truth was somewhere in between, and Chevrolet wasn't eager to explain. Secrecy became part of the weapon. Confusion helped. If competitors didn't know what they were fighting, they couldn't effectively counter it. If Ford engineers couldn't get specifications, they couldn't design specific responses. Mystery itself became strategic advantage. But secrecy couldn't hide one fact. The engine was fast, very fast. At Daytona testing sessions, the cars demonstrated speeds capable of challenging Ford's best efforts. Lap times impressed everyone watching. Trap speeds on straightaways raised eyebrows. Teams reported stronger acceleration and better high-speed breathing than many rival combinations. Drivers said the power delivery felt more usable than previous Chevrolet engines. Crew chiefs appreciated the torque characteristics. For a brief moment, it looked like Chevrolet had found the answer, the engine that could dominate NASCAR for years, the engine that could finally restore Chevrolet's supremacy, the engine that could make Ford and Chrysler play catch-up instead of leading development. But there was one enormous problem: General Motors itself. Officially, GM's corporate racing ban remained in effect. The Automobile Manufacturers Association agreement from 1957 discouraged factory racing involvement. GM executives had publicly committed to that position. They'd made statements. They'd issued policies. They'd told the world that General Motors wasn't interested in racing. Executives feared public relations issues and government scrutiny. Congress was paying attention to automotive safety. Regulators were asking questions. Some politicians criticized manufacturers for promoting speed and performance. Open factory racing support was politically difficult. The engineers had built a weapon. The racers wanted to use it, but corporate leadership wasn't fully committed. Support came in whispers, not announcements, through backdoor channels, not official programs, with quiet assistance, not public backing, and that changed everything. What happened next would determine the engine's fate. Instead of receiving years of development like Ford's racing programs, the mystery motor existed in a strange limbo. It was powerful enough to win, but it wasn't supported enough to evolve. Not properly. Not with the resources needed to transform a promising prototype into a dominant racing platform. Not with the time required to solve every durability issue. Not with the factory backing that would have made it truly competitive season after season. Engineers continued refining the design, solving lubrication issues, strengthening components, and improving reliability. They worked with what they had, made incremental improvements, addressed the most critical failures first. The architecture proved so promising that it eventually became the foundation for Chevrolet's famous Mark IV big block family, the same family that would later power legendary engines like the L88 427 and countless high-performance Chevrolet muscle cars. The same basic design philosophy that would dominate drag strips and street races throughout the muscle car era. In a way, the mystery motor never truly disappeared. It evolved, it transformed, it became something bigger. The lessons learned from its failures informed future designs. The successes were incorporated into production engines. The architecture lived on in different forms. But the original engine itself, its life was astonishingly short. Only a limited number were ever built. Estimates vary, but most sources suggest fewer than 50 complete engines were assembled. Some say the number was even lower. Exact production figures remain unclear because official documentation was deliberately vague. Many were raced hard, pushed to absolute limits, run at full throttle for hours, subjected to abuse that would destroy normal engines. Some survived, many didn't. Some were destroyed. Failures on track, catastrophic mechanical incidents, engines that scattered parts across racetracks, blocks that cracked, components that disintegrated. Others were dismantled as technology moved forward. Engineers cannibalized them for parts. Teams scrapped them when better options arrived. What seemed cutting edge in 1963 became obsolete as development continued. Today, surviving examples are incredibly rare. Finding an authentic mystery motor is extraordinarily difficult. Verifying authenticity is even harder. So many stories, so much mythology, so few documented survivors. Collectors will pay enormous sums for authentic components because they represent a missing chapter of American racing history. Not just the engine itself. Even individual parts command premium prices. Cylinder heads, blocks, crankshafts, connecting rods. Anything verifiably from an original mystery motor becomes a treasure, a glimpse into an alternate future. A future where Chevrolet openly challenged Ford with a factory-backed racing monster years before the muscle car era reached its peak. A future where GM embraced performance instead of hiding from it. And that's what makes the mystery motor so fascinating. It wasn't designed for comfort. It wasn't designed for longevity. It wasn't even designed for production. It was built for war. A secret weapon created during one of the fiercest horsepower battles America had ever seen. The engineers knew it would be pushed beyond reasonable limits. They knew parts would fail. They knew entire engines might be sacrificed chasing victory. They accepted those realities because the alternative was worse. The alternative was losing, because survival was never the primary goal. Winning was. Victory justified everything. Justified the secrecy, justified the expense, justified the failures, and the destroyed components, and the constant stress of operating outside official corporate policy. In the end, the mystery motor didn't become famous because it lasted forever. It became legendary because it changed everything that came after it. Without it, there might never have been the iconic Chevrolet big blocks that dominated drag strips, stock car tracks, and muscle car streets throughout the late 1960s. The Mark IV family owed its existence to lessons learned from the mystery motor's brief, violent life. Its lifespan was short, its impact was enormous. And that's the real story behind the Chevrolet 427 mystery motor, an engine born in secrecy, built for battle, never truly meant to survive, just meant to win. If you enjoyed this story, let me know which forgotten racing engine you'd like to see next. And make sure to subscribe so you don't miss the next deep dive into the machines that changed automotive history forever.